Good evening, students. Today we are discussing Module 1 of Surveying. The name of module is Introduction and Basic Concepts. Definition of surveying. So it is the art of a science which determines the horizontal distances by means of tape and chain, and determining the elevation with respect to with the help of dumpy level or auto level, and determination of direction with the help of prismatic compass, surveyor compass, etc., and determination of angles with respect with the help of theodolite, and to find the location and to calculate areas and volumes above or below the surface of the earth. This is the definition of surveying. So it involves the measurement by chain or tape and recording whatever you collected data in the field that you have to record in the books, field books, to the size and shape. That means you have to draw the drawing and you have to enter the measurements in the drawing according to that shape, whatever you measured, including vertical shape. Suppose if you find any elevation that you have to mention in the vertical form of an area on the surface of the earth. So this is the definition of surveying. So what are the objectives of survey? You have to collect and you have to maintain a record of data, whatever you have collected on the surface of the earth, and you have to calculate areas and volumes in the office, and you have to prepare drawings like plans and maps in the office. Plan is a pictorial representation of your data collection in the form of a drawing. So plan is drawn to a small scale and map is drawn to a large scale. You know, building plan, etc., comes under plans. India map, world map, etc., comes under maps. So these are drawn to suitable scales. And moreover, the main objective of survey is to lay out engineering works like reservoirs, dams, etc., by using the collected data, survey data. And one more thing, you can check the accuracy of already laid out works. Already laid out works, you can also check the accuracy of works. So mainly basic principles of surveying are two. One is working from whole to part. You have to divide the entire area into number of parts and you have to do survey, but not from part to whole. Part to whole you should not do. You have to do only from whole to part. Whole area can be divided into parts, then you can start survey. That system you have to follow. Suppose in the diagram, if you see PQ is the line you have to survey. Then R, S, T, U are intermediate points which are divided into number of parts. Likewise, you have to do survey whole to part. You should not do it from part to whole. If you do part to whole, the error will be increased. Error will be magnified. So you should do from whole to part. Then in the last diagram, third diagram, bottom diagram, the error will be localized. So you can eliminate the error where it is occurring. You can able to know where it is occurred so that you can eliminate at that particular point. So you should do from whole to part, but not from above two figures part to whole. Okay. If you do survey from part to whole, the error will be increased and magnified. Where the error was occurred, you cannot know. It goes on increasing. It will be some large amount at the end of the day work. So you should do from whole to part. Second principle is locating of third point by known reference points. Okay. So this can be located by rectangular coordinates, polar coordinates, or by two angles or one angle, one linear measurement. Like that, you can locate third point. Here are the diagrams which I earlier described in the previous slide. Locating points by independent measurements. See first figure A, rectangular coordinates. PQ are our known reference points. You have to establish R. So at R dash, you have to provide a crossstaff and you have to see whether PQ is in line with that crossstaff markings. Crossstaff central marking. So if the crosstalk horizontal line is matching with the PQ line, then you can establish R point to the perpendicular of PQ. So that is the method of fixing R, one method. Second method is trilateration. In this, you have to measure PR and QR of known distances where these are intersecting with each other. With these two measurements where they are intersecting with each other, that is the point R. In the third point, one angle theta from P, if you know that angle R can be established with the help of theta. In the same ways, beta also from Q, you can establish R point. So this is polar coordinate method. And D, coming to D, one measurement, linear measurement, and another angle. From P, PR is linear measurement. From Q, angle beta is angle. Where this linear measurement and angle beta are intersecting, that is the point R. Okay. Next, in E, triangulation method. So here both are angles. From P, theta angle, from Q, beta angle. Where these two angles are intersecting, that is point R. So this method is called triangulation method. Next one, F, check lines. Check lines. So here you check lines means to check the accuracy of work. So PQ are our known reference points. R dash is perpendicular line to the PQ. Okay, by using 3, 4, 5 method or Pythagoras theorem, you can check RS. RS is a diagonal of RR dash S triangle. So it is a right angle triangle RR dash S. So if RR dash is 3 meters and R dash S is 4 meter, then RS will be 5 meters. That is Pythagoras theorem. So like that, you can check the this RR dash is perpendicular to PQ or not by measuring RS. If it is comes to 5 meters, when RR dash is 3 meters, R dash is 4 meters, it should be RS should be 5 meters. So your work is perfect. That means RR dash is perpendicular like exactly 90 degrees to the PQ. Likewise, you have to check the RS. That is called the check line. Next topic is classification of surveys. Broadly, survey can be classified as two types, plane survey and geodetic survey. In plane survey, the area to be surveyed is very small and the curvature of earth should not be taken into account. That means the curvature of earth is ignored in this plane survey. Okay. And the difference between arc and chord is small. So this is called plane survey. If you come to geodetic survey, wherever high precision, high accuracy survey required, there large amount of area is there you have to apply geodetic survey. Here in this survey, in this geodetic survey, curvature of earth is to be taken into account. Okay. So many other correction in measured quantities are done for higher precision. So here we have to for higher precision, this type of geodetic survey is most useful. Next, based on instrument, the surveys can be classified as chain survey, compass survey, plane table survey, theodolite survey, leveling, tachometry, EDM survey. That means electromagnetic distance measurement, total station survey, remote sensing, and satellite based survey. So if you use chain, it comes under chain survey. If you use prismatic compass or surveyor's compass, it comes under compass survey. Likewise, depending upon the instrument, what are instrument you are using to do survey, that survey is classified under instrument based survey. If you suppose you use plane table by radiation method or intersection method, it comes under plane table survey. If you use a theodolite for making vertical angles or horizontal angles, that is called theodolite survey. If you want to find out elevation of some stations or to find out the beam bottom RL, that is called leveling. If you use a tachometer in the theodolite, it comes under tachometry. If you use EDM, then it is called EDM survey. If you use a total station instrument, it is called total station survey. If you use remote sensing and satellite based survey, if you are using it, it also comes under remote sensing satellite based survey. Next, depending upon methods, which method you are following, that is called method based surveys. These are triangulation, trilateration, traversing. You know traversing. There are open traverse and closed traverse are there. Where you are start and where same at the same place if you are end, that is comes under closed traverse. Open traverse will not close at the same starting point, that is open traverse. Next, leveling, tachometry, trigonometrical leveling by using some trigonometrical relations and expressions, that is comes under trigonometrical leveling. So these are all called method-based surveys. Next, purpose-based surveys. Purpose-based surveys. Reconnaissance. Reconnaissance is a initial step of the survey where you are taking, where you are finding, or where you are locating where the hills are, where the canals are, where the ponds are. You have to locate the some features in this survey, in this reconnaissance survey. It is a rapid and rough survey. It will give approximate, you can locate approximate positions of features, topographical features in this reconnaissance survey. Next one, preliminary survey. In this survey, in this preliminary survey and engineering survey, you have to use, in preliminary survey, you can use instruments like dumpy level, theodolite, total station, etc. With very high accuracy measurements. That survey is called preliminary survey. Next, for engineering works, to construct a road or street or to laying out a sewer line, canal, to fix the center line. These are to fix a to construct a reservoir. These are all comes under engineering survey. Next, geographical survey. Geography, how the geography is, to know that that survey is called geographical survey. Mine survey, to explore the mineral wealth, where the coal mines are, where the gold mines. Like that, if you want to find out mineral wealth, that surveys are comes under mine surveys, below the ground level, underground. Next, route surveys. Route surveys are used to do in the traffic surveys. So which route is more demand, which is having more demand, and which route is giving more income to the government. To select that final route, 2-3 alternate route surveys are surveyed. In that, which route is giving constructing with less cost and giving maximum revenue to the government, that can be finalized as route survey. Okay, so these are purpose-based surveys. In the same way, purpose-based surveys, location survey, geological survey, that means geology. What is the strata of the earth? What are the layers in the earth? To find out that geology, that is called geological survey. To find the location, to determine the location, it is comes under location survey. Next, defense survey. Defense survey law, this military people will do this survey, that comes under defense survey. And archaeological survey, to explore the unethical movements, that means which are embedded in the ground, like that. These archaeological surveys can be done. So these are all called purpose-based surveys. Again, next one, place-based surveys. So above the land, if you do survey, it comes under land survey. Above the water or below the water, if you do survey, that comes under hydrographic survey. To determine the depth of water, you can you have to do this hydrographic survey by taking soundings. Sounding is a equipment which takes the depth of water from water level top to bottom of the top of the bed. It gives the depth of the water. So this type of survey comes under hydrographic survey. Generally, this type of survey will be used for marine engineers. Next, aerial survey in space. If you do survey, it comes under aerial survey, space. Underground survey. If you do survey below the ground level, like to explore the mineral wealth, like mine survey, it comes under underground survey. Next, we have survey instruments. To do surveying, we need instruments. But these instruments are to be handled with utmost care, because they are very delicate and sensitive. These leveling instruments, these surveying instruments are very delicate and sensitive. So utmost care is to be taken while using these type of instruments. What we have to do, to follow manufacturer's instruction. So for every instrument, we will get a manual. So read the manual and follow the manufacturer instruction. Next one, keep the instrument in the box or cover properly. Okay, after your work is completed, keep that instrument in the box provided. Protect the instrument from sun and rain. Take an umbrella and protect your instrument from sun and rain. Take care of optical parts. The instruments, some instruments consist of eyepiece and screws. Theodolite consists of eyepiece, optical plummet, lower clamp, upper clamp, lower tangent, upper tangent. So these should not be tightened too much and should not be loosened too much. So care to be taken while using of these optical parts. Okay, you should not tight very too much, right? It will be damaged. It will get damaged. Next, proper use of instruments in the field. In the field, you have to use your instruments proper way. And temporary adjustment should be done at every station. Temporary adjustment should be done at every station. Next, coming to what are the qualities of a good surveyor should have. He should have sound knowledge of theory. He should have sound knowledge on the subject. He should have sound knowledge of instruments. And he should know the limits of precision. He should know what are the possible errors and how to maintain. He should know. And he should have a good practice in the field. He should have proficiency in using the instrument. He should know the accuracy and he should have a judgment capacity. And moreover, he should have leadership qualities to guide the team members. And he should have good professional conduct. So these are the qualities of a good surveyor. One should have these qualities. So what is the difference between plan and map? Plans and maps are graphical representations. What are the measurements you have taken in the field? That should be pictorially represented on the drawing sheet. So these are called graphical representations. So these are projections of a spherical surface on a plane. Distortions occur during such representation. In the case of small area, such distortions are small and they are negligible. They can be accepted for small areas. Next, scales. The plan or map are to be drawn to a suitable scale. The scale is represented by the following three methods. First one, 1 centimeter equal to 10 meters. That means 10 meters measurement on the ground, you are representing on the drawing sheet as 1 centimeter. And second method, RF, representative fraction. This 1 centimeter, you are keeping in the numerator, that is 1 centimeter. And in denominator, 10 meters you are converting into centimeter. So 1 meter equal to how many centimeter? 100 centimeter. So 10 into 100, that is equal to 1000 centimeter. So you can represent the scale as 1 by 1000. Okay? 1 centimeter by 1000 centimeter. Centimeter will get cancelled. You will get 1 by 1000 is RF. RF means representative fraction. And the next third method, or you can use the scale as graphical representation. Okay, so these are the three methods to express your scale. So what are the errors? Errors may be three types. For any instrument, the errors can be three types. First one is instrumental error. Second one is personal error. Third one is natural error. So coming to instrumental error, instrument not in adjustment and wear and tear, faulty manufacture. So it's a permanent adjustments gone damaged. That comes under instrumental fault. Temporary adjustments we have to do at every station point. If permanent adjustment fails, it should be repaired. It should be taken to the workshop. Okay, and the parts may be wear and tear and due to faulty manufacture, etc. comes under instrumental faults. Second one is manipulative errors. The human error means our error of reading. You are reading something and you are note down something. So if you read leveling staff 1.05 and you record 1.50, it comes under manipulative error or personal error. That is your mistake. You are reading 1.05. That should be written on the book, but you are writing 1.50. it is called manipulative error, personal error. And wrong manipulation of controls. So vertical control, horizontal control, if you do in the wrong manipulation, it also comes under manipulative errors. Third one is natural error. Earth is a spherical shape of, Earth is having spherical shape. Due to that, curvature error, refraction error will occur. So this curvature, refraction, and wind conditions, temperature, and presence of magnetic substances, these are all natural causes. So due to curvature of Earth and refraction of Earth, some errors will occur. And during high wind, if you take measurements, that will be readings will be erroneous. And if you take readings and if you do survey in the mid temperature, mid noon, in summer, it will give wrong readings. And in the presence of magnetic substances in the ground, if you do survey with compass, the local attraction will occur. So these are all comes under natural causes. So how to eliminate these type of errors? Instrumental errors can be minimized by eliminated by frequently check the instrument for permanent adjustments. So you have to check for permanent adjustment. Suppose horizontal axis should be at right angles to the vertical axis. The axis of bubble tube is parallel to the line of sight. These are the some relations between fundamental relations between fundamental lines in the theodolite. So these are to be checked frequently. Then the permanent adjustment can be done by ourselves if they satisfy the relations. Otherwise, if they are showing some angle with not a perpendicular, if they are showing with any error, it should be taken to the workshop for repair purpose. Keep the instrument maintained and calibrated by trained technician. These instruments are periodically calibrated, should be periodically calibrated. These instruments has to be periodically checked by technicians and they are to be calibrated by a trained technician and maintenance to be done periodically. Handle the instrument very carefully. Protect it from sun, rain, dust, and moisture. With the help of umbrella, you can protect your instruments from sun and rain. By covering with a cloth, you can prevent dust entering into the instrument and moisture when no usage of your instrument, when it is not in use. So that is elimination of instrumental error. Now, how to eliminate the manipulative error? Operator should study the operation manual of the instrument carefully before handling it. Whatever the instrument you are handling, you should know what are the manual given by the manufacturer. You have to thoroughly study that manual and you have to understand that operation, how to do. Then you have to operate the instrument. The technology has improved so that much less reliance on human expertise in handling is required. Citing, reading, and recording errors should be avoided. So when you are, whatever you are citing, whatever you are reading, the citing and reading should be matched. And whatever you are reading, that only should be recorded. Then only the manipulative errors can be eliminated. Whatever you are perfectly bisecting the object, that reading only you have to read and that only you have to record in the books. Then you can eliminate this manipulative errors. Modern instruments eliminate most of these errors because automatically all these modern instruments will have display. They are having display on the screen. So you need not read the measurement. It will display on the screen, horizontal distance or horizontal angle, vertical angle. It will be displayed on the suppose total station. If you use total station, if you want to find out the horizontal distance from instrument station to object, it will clearly display the length, I mean horizontal distance or vertical distance or horizontal angle, vertical angle, whatever you want, it will be displayed on the screen. So modern instruments will eliminate most of these manipulative errors. Errors due to natural causes. So important measurements are taken at the same time on different days. So if you have to do survey continuously, then at the same time you take the readings. Today morning 10 o'clock, tomorrow morning 12 o'clock, don't do. Daily 10 o'clock you do the survey. Corrections to be applied for the quantities. So you have to apply corrections like if it is tape, sag correction, pull correction, it has to be applied. Okay. Use appropriate methods and precautions to avoid such errors. So you have to use appropriate methods and you have to use precaution to avoid such type of natural errors. Manufacturer instruction you have to follow for minimizing errors. You have to follow the manufacturer's instruction to minimize the errors. Next, this is conventional symbols. So chain line is represented by dotted line. On the drawing, on a plan or a map, you have to use this type of conventional symbols to describe some details. Chain line can be represented like this, dotted line, dot dash, dot dash, dot dash. Triangulation station can be represented like this triangle. Traverse station can be represented like that, circle A. Next, building is represented with a hatched line, and a shed with open side like a dotted box in that hatched line. Shed with a closed side should be closed on all sides. And for the building and the shed with closed side, if you see the difference, building is closely your hatching lines are there. In the shed with closed side, some space is more. Hatching space is more. Next, temple, mosque, and church. Temple, mosque, and church can be represented like this. First one is temple. Second one is mosque. Third one is church. Like that. Next one, path. That is way. It can be represented like that. Next, unfenced road. Unfenced road should be represented like this. There is no fencing. That means next to fenced road. Fenced road can be represented like this. Like this. Fenced means curb, footpath. So if there is no footpath, it is represented like this. If there is footpath or fencing, it is represented like this. Single track of railway line and double track of railway line and road bridge and level crossing. You know level crossing, where the road and the railway track are crossing with each other. That is called a level crossing. It is represented like this. Next, road over railway. See here, bottom railway track is going on. At the top, your road is going on. So this you can see at Modali flyover. Okay. Next, road under railway. So road is going at bottom, railway track is going at the top. Next, boundaries without pillars. So pillars without pillars, boundaries should be shown like this. Boundaries with pillars are represented like this to this way. These are pillars. These are pillars. Next, township and river. River can be represented like this, but flow direction to be mentioned. In which direction water flow is going? Water is going in which way? That arrow mark should be provided in the river. Next, pond or lake is represented like this contour. Okay. And electric line is represented like this, and trees are represented like this. Orchard, that means a group of grape-like trees, plants, and wood forest like this, and grass vegetation like this. Cutting and embankment should be represented like this. Cutting means valley, embankment means like a hill. Okay, and the north direction you have to mention in the drawing like this. Okay, arrow, which direction is north, that you have to write N, right? So these are called conventional symbols. These are used in the plan or map. Shrinkage of map. When these maps are using day by day, they will get a shrink after so many years. In world map, graphical scale is not shown. Only RF is written. In the olden days, they will use only RF. They will write only, they use it to write only RF value on the map. Okay. Map get shrinked after some years. 2 points picked and length calculated using RF. So on the map, whatever the map gets shrinked, in that 2 points are to pick it up, and the length between 2 points has been calculated with the help of RF value, because in the old maps they use only RF value. So with the same RF, you have to calculate the length for 2 points. Same point distance measured on the ground. Now you measure the same points distance on the ground. Wherever you plotted the drawing, same points you measure on the ground. Then remaining distance and areas are calculated. Shrinkage factor is equal to calculated length by measured length. That is the formula. Shrunk scale is equal to shrinkage factor into original scale. So further reading of map may be done with the original scale. So these are the code of signal while using ranging. So if you use this right hand, he should move the observer, the staff man, the ranging rod person will move to this side. If you use a right hand stretch, so you have to move very long distance. You have to move in that direction. Okay. If you keep hand near the head to right side, it is your ranging rod is not in plumb. You have to make it the plumb by this direction, like that. In the left side, you have to go this direction. The very long direction you have to go, long length. Here, some short distance you have to go. Okay, this point is okay. For this, you have to use this signal, and this is yes, that point is correct. And this is okay. You fix the ranging rod. That is the signal for fixing the ranging rod. And this is the hand upon head, which is used to come back to your position. Your work is over. You can come to reach me. So these are the code of signals. These are used in ranging process. Okay. So that is the explained here. Rapid sweep with right hand, move considerably right. Rapid sweep with the left hand, move considerably left. Slow sweeping with right hand, move slowly to the right. Slow sweep with left hand, move slowly to the left. Right arm extended, continue to move the right. Left arm extended means continue to move to the left. Right arm up and move to the right. Plumb the rod to the right. Your rod is not in the plumb, so you have to move the rod to the right. Left arm up and move to the left means plumb the rod to the left. Both arms above head and then brought down means correct. The point is correct. For that, you have to show like this. Both arms extended forward and depressed briskly. That means, yes, correct. You can fix the ranging rod. So these are the code of signals during ranging. What are the phases of surveying? There are 4 phases. First one is planning, analysis, decision making. You have to plan where the survey is to be carried out. You have to analyze and you have to take decision. Second one is care and adjustment of instrument, not case, care. You have to take care and you have to do temporary adjustments for the instrument. Next, field work. Next, office work. These are the 4 phases of surveying. In the first phase, you have to select an appropriate method of surveying. Which method is suitable for you at that particular place? That method you have to select. Selection of instrument and other equipment. Which instrument is suitable for that particular survey? You have to select the instrument. Next, selection and fixing of survey stations. You have to fix the survey stations. You have to fix the survey stations. Second phase, care and adjustment of instruments to ensure the best results. The surveyor must check the permanent adjustment of the instrument are not disturbed. So all the fundamental relations are satisfying for permanent adjustments or not. These are to be checked by surveyor. So this instrument should be in good working condition. So that is second phase. In the third phase, you have to go to field. It is the process of collecting field data by taking measurements, by note down the measurements in the record, by making linear measurements with the help of chain or tape, and angular measurements with compass or theodolite, and recording whatever the observations you have taken in the field, that should be recorded in the field book in a systematic manner. That is the third phase. Next, last phase is office work. You have to get back to office, and this office work consists of 2 parts: computation of coordinates and data processing. And third part is preparing plans or maps to suitable scale. Fourth point is computation of areas and volumes. Okay, so in office work, you have to calculate the coordinates and you have to process the data and you have to prepare or draw the plan or map to a suitable scale. What are the data collected from the field? With that given data, you have to draw the plan or map. And you have to calculate areas and volumes with the help of surveyed data in the field. Next, E student. setting out works. It involves pegging out the structure on the ground before construction starts. So you have to lay out, you have to mark with the help of powder, lime powder, you have to mark the center line and edge lines if it is road work. Like that, you have to setting out the work. So these are the phases of surveying. Next, what are the accessories are used in the surveying? Arrows, you know, the length of arrow is 40 centimeter, diameter is 4 mm, made up of galvanized iron, wooden pegs, ranging rod of 2 meters or 3 meters, plumb bob to fix the, to transfer the ground point exactly over the instrument, and the lats and offset rods. Offset rods are square rods, and they will provide, they will be provided with some hook arrangement to pull the chain if it is struck with any bushes. It should be pulled with that offset rod with the help of that hook arrangement. So these are the accessories of surveying. These are the accessories of surveying: arrows, pegs, ranging rod, ranging poles, plumb bob, lats, and offset rod. So this is the surveying subject, module 1, introduction and the basic concepts. Okay. In the same module, next topic is chain surveying. That means horizontal measurements. And next is the third topic is measurement of directions. Measurement of direction, that is compass surveying. That will be discussed in the next videos. Okay, today we will close this with this last slide, accessories of surveying. Okay, have a good day.